All right, welcome back. In this section, we are going to focus on the zeros of a polynomial. Now, we've already talked about the zeros of a polynomial when we were looking in the first section as far as identifying the x-intercepts. But those problems, we had the equations were typically in factored form. They were already written as a product of its factors, and therefore to find the zeros, we could just set each and every factor equal to 0. And that was relatively nice. However, in this chapter, or in this section, we're going to be looking at polynomials that are not in factored form. So hopefully you can connect the dots if we like them in factored form, and we're going to be dealing with problems that are not in factored form. We're going to be doing some practicing of factoring to get our polynomials in factored form, so therefore we can set them equal to 0 to find the zeros of the polynomial. Now, this section is called zeros of polynomials, but actually what we're going to focus on is the real rational zeros of polynomials, and we'll get into the irrational and complex in the other two sections. Now, in addition to identifying the zeros of the polynomial, we know that also the multiplicity plays a part, because when we looked into graphing in section 1, we found that the multiplicity plays a big part in understanding what is happening at each and every x-intercept. So in this section, what we're going to do is we're going to find the zeros as well as the multiplicity of a polynomial. And again, they're not going to be in the factored form or always in the factored form like in section 1, but a lot of times we're going to be practicing factoring to identify those zeros. So the way that I kind of like to introduce this is looking at a set of different examples just to kind of remind you of the factoring process. This is something that we've already kind of gone through as far as factoring trinomials, but once we start getting into polynomials that are going to have higher powers, we need to really make sure that we have the fundamentals of factoring down put. So let's look at this first example. In the first example, you can see there's only one term that is only one variable, and it's x squared. So remember, when you only have one variable, to solve for that variable, you can just use your inverse operations. So you can add 4, take the square root. And again, the important thing about this is when you take the square root, you have to include plus or minus, because again, you don't need to use what we call the inverse operations or the square root method here. You could also factor that by the difference of two squares. By factoring it and writing it as a product of factors, which is a preferred method, you can see that there are exactly two factors as well as two solutions. So if you use the square root method, that is fine, but just remember when you introduce the square root, you have to make sure you include the plus and minus, because obviously there are two zeros in this scenario. Now, for the next example, we cannot use the square root method, or you cannot add 4x to the other side and then take the square root. The reason being is there's actually two variables. You have x squared and you have the negative 4x. So in this case, when we have more than one variable, you need to look at our factoring techniques or our solving techniques for quadratics. Look at factoring, quadratic formula, or what we previously talked about last section, completing the square. And preferably, we always want to look at factoring first. That's usually going to be our easiest method. And in this case, we want to see what is it that they have in common that we can factor out. In this case, they have an x in common. So therefore, I can write it as my factored form, x times x minus 4, apply the zero product property, and go ahead and solve. Now, again, I did not mention this, or I did not label them, because one thing that I tell my students is if the multiplicity is 1, then we will just go ahead and assume that this multiplicity is going to remain at 1. So in this case, you can see that so far all of my zeros have a multiplicity of 1. But in the next example, you can see as we go ahead and factor this, we recognize that this is a perfect square trinomial. So when you factor it, even though it gets to x minus 2, that is what we call a repeated factor, right? It's a repeated 0. So even though there's only one 0, x equals 2, it got repeated. And by understanding multiplicity, we know that the behavior of that graph is going to bounce at 2. It's going to behave like a quadratic. So the 0 is x equals 2, but it has a multiplicity of 2. And so that is going to be your factored form when you have a trinomial, x squared minus 4x plus 4. And then the next factoring technique that we are going to kind of practice in this section is going to be factoring by grouping. So factoring by grouping is going to occur when you have a polynomial with 4 terms. And when you have a polynomial with 4 terms, what we're going to want to do is group the first 2 terms and group the last 2 terms. Then, just like in example number 2, you're going to look into factoring out the common factors of each of those terms. So for x cubed minus 2x squared, you can see that they have an x squared in common, so you're going to factor that out. As far as the negative 4x plus 8, you can see that they have a negative 4 in common. So when you factor out the x squared and the negative 4, you recognize that x minus 2 is in common with both of those expressions, right? Those expressions are still separated by the addition symbol. So here's one expression, here's the other expression. By factoring out the common factor, you can see they both share an x minus 2. Now, just like factoring out the x here, I can factor out the x minus 2. By factoring out the x minus 2, I get a x minus 2 times x squared minus 4, right? The x squared minus 4 is what's left over. Now I have a product equal to 0. I set each factor equal to 0. Again, notice this is not written in linear form. So therefore you could factor it to x minus 2, x plus 2. Or in this case, you can go ahead and just add the 4 and take the square root. Therefore, you get x equals plus or minus 2. However, please note, again, those are all going to have a multiplicity of 1. The only example where we have a 0 with a multiplicity of 2 is this middle example, and that is because the factor is being raised to the second power. This is not the factor being raised to the second power. This is x being raised to the second power inside of the factor. So just make sure you recognize the difference between this and that, because this gives a multiplicity of 2, where this is still going to have multiplicity of 1 once you go ahead and solve. And in addition to finding the zeros, we are going to use this information to also kind of work backwards. So you can see what we did here is I gave you the equation. We went to go ahead and factor it, and then to go ahead and find the zeros. So the other thing we're going to practice in this section is if I give you the zeros, to set the zeros as factors equal to 0, to write them in factored form equal to 0, and then to multiply them to write the equation. And so that is the other point of this chapter, is not only to find the zeros and the multiplicity, but to take the zeros and the multiplicity to be able to identify the equation. And again, we'll work through those step by step for you in the process video. I just want to make sure you understand that the zeros is going to be the values that make your equation true when it's set equal to 0. So you're going to replace y or your function notation f of x equal to 0, and you're going to want to solve. Typically, when we're dealing with more complicated problems, you're going to need, if you have more than one variable, you're going to be looking into factoring, and we're going to practice multiple factoring techniques to go ahead and write your polynomial as a product of linear factors equal to 0. Then you can apply the zero product property and go ahead and solve. So that is what we're going to be covering in this section. All of our zeros are going to be real and rational, and then we'll go ahead and work backwards as far as given the zeros to write the equation. So before you go ahead and get started on the processes, go ahead and take a look at the notes. I have many, many more examples of factoring and finding the zeros, but we want to make sure that you have a good foundation before we get going. I'll see you on the next video. Cheers.